Good morning, good afternoon, good evening, and good night, friends and colleagues from across the world. Welcome to today's webinar, where we'll be looking at Dental Printing 101. I have a great honor to host Dr. Spagnoli, Mr. Tyler Britt, and Ms. April Newell. Thank you for joining us today.
Of course.
Pleasure.
They will guide us in getting you guys sort of started with dental printing, which we believe will be the future in our industry as terms of prosthetics. I have recently started printing crowns, dentures, night guards, and my remake cases on my crown and bridge have gone down tremendously. So for those that are kind of getting tired of the manual remakes and the cost that we endure, this would be a good session for you, but we're also going to look at it from the oral surgery perspective for all of our implantology friends out there. Before I go into reading off the bios of our three speakers today, some housekeeping stuff. As you may know, registration has now opened up to the World Gala, which will be held with the Italian Dental Association in Sardinia, Italy, and you're welcome to start registering it. I will give you guys a brief overview of that scenario via this diagram here. So the gala will entail a symposium, which is conducted by the Italian Dental Association. Down in the links below, you will find the registrations link. Scientific session, we have an exhibition. It's a red carpet event at a 5-star hotel in Sardinia, which is closer to the Rome area. And there's going to be a lot of action there. So tremendous networking opportunity of doctors under the umbrella of our doctor-to-doctor movement. With that said, you're welcome to go there and begin registering for the Congress and also pre-registering for the World Gala. All right, so Dr. Spagnoli, you have quite a career. Doc has been an oral surgeon since 1989, so likely he has seen a lot of things come and go. He was board certified in 1991. By the American Board of Oral and Maxillofacial Surgeons. He's also a past board examiner. Following his residency, he entered private practice in Charlotte, North Carolina at the University Oral and Maxillofacial Surgery, which eventually became the Carolina Center for Oral and Facial Surgery. He's also the past director of oral and maxillofacial residency training at the Carolinas Medical Center, and he's the past chairman of oral and maxillofacial surgery at Louisiana State University Healthcare System. Currently is in private practice at Brunswick Oral and Maxillofacial Surgery located in Supply, North Carolina. Wow, Doc, several decades of doing this, now from the manual to the digital. Usually they say the older generation doesn't like to learn new technologies, but that's certainly not the case here because you're teaching it. Thank you for coming in. Tyler Britt, he has been with Doc for many years, and he has sort of done also some volunteer work in this space. He became an employee with the Brunswick Oral and Maxillofacial Surgery, and he'll tell us a lot about the laboratory perspective of the printing innovations that are coming out in the marketplace. They began to work together and created a system where they could provide facilitated, accelerated treatment to patients in a much more accurate and predictable approach. And April has been working with me on getting us oriented in our practice for the new 3D systems and seeing all of the benefits that it brings to my practice now. I recommended we do a webinar so our colleagues can benefit from the same. So, guys, thank you for joining in. Perhaps we can get started a little bit with the oral surgery perspective. A lot of our viewership are implantologists. They have challenges with not only, I don't know, are you guys making your surgical guides using this printer as well, or how does that work?
Yes, we make all the guides printed.
You print all of your guides, and then also you do all your conversions in-house. Do you do it the same, essentially same day? You place the implants guided, and then I assume, Tyler, you go in and convert those cases?
Yes. For our big full arch cases, we most of the time will do those same day. It's gotten so efficient. In the past, before this technology was really available, it was a little bit more difficult to do because you just didn't want to have patients under anesthesia for that long. But with the technology advances now with 3D printing, we can do everything so much more efficiently, and it's become much more feasible to do a case same day, full arch, dual arch. Well, we have a case tomorrow, a dual arch, where we're converting and doing guides, implants, teeth, and everything same day off of the 3D printer.
Yeah. That case includes zygomatic implants.
And doing zygos too. So let me ask you a question. You're planning everything, you do everything right, and you go in there and you place 4 implants. And then you get a spinner in there, and you got your prosthetic already made, your conversion prosthetic. How do you handle that situation, Dr. Spagnoli?
Well, it's a great question. First, I would say that we do occasionally have an implant that we will not load, but it's quite rare. Part of that is because with very diligent, very accurate imaging, and we also will look at Huntsville units, we pretty much know where we're placing our implants. So we steer clear of areas that we do not feel will make our criteria. We like to place all of our implants to achieve 30 Newton centimeters of torque. Now, occasionally we'll come up a little bit short of that, but as long as cumulatively adjacent implants are over that, we will still load it. But if we get an implant that is down below 20 or so, we might let that one sit. As long as things are bracketed, we're okay with that. But it's quite rare. I would say I can think of 3 or maybe 4 situations in the last 7 years.
Excellent. So, wow, that's a pretty accurate system you have established. So, Doc, at what point did you decide to go from manual to digital, where you transformed your practice in that capacity, and what was the reasoning for it?
That's another great question. This is a little bit of necessity is the mother of invention. We have, even when I was back at LSU, we were, providing numbers of full arch restorations, and we were working with some extremely talented and very good dental labs. And we went from, of course, more of an analog to a digital path over time. The problem was I was never getting the fit I wanted. I wasn't getting the accuracy. And I think a lot of it was understanding vertical dimension. It's really the key. That's where I said, I'm going to step back. I even sat down with the labs and with articulators and showed them how we would manage vertical dimension if, for example, we were doing orthognathic surgery. Because in principle, it's the same thing. So we really went back to the drawing board, and we said, we want to have virtual articulators, and we want to be able to lock in vertical dimension once we obtain it and make sure that we don't deviate it. And if you can obtain really good records, have a really good vertical dimension, then things fit. But if you have an auto rotation issue in surgery, or you have a cant that you didn't pick up, so any discrepancy like that you can't correct, in your bone leveling, et cetera, you're going to have problems. So a lot of it comes down to details. And I wanted to we wanted to take a path that would get us to that level of accuracy. And that's really where we're at now. It's very rare that we even have to modify a prosthesis. Tyler has the holes in the prosthesis and they slip onto the cylinders.
Wow. Dr. Pico is a good friend of mine there in Florida. I just visited his training facilities, and he uses N-sequence. Is that your protocol? You go through the N-sequence process?
Actually, great respect for, Joe Berger and Ian Ayers out there on the West Coast really did all of the developmental research. that led to end sequence. And they're both good friends of mine. In fact, they were both to lecture at LSU while I was there, and they really broke the ice on all of this. The problem is, I'm a very respectful person. I love both those guys. The problem is they base their therapy on alveolar bone. And unfortunately, alveolar bone is not predictable enough. And so that is the downfall of that system. And that's why we don't use it. So as a surgeon, we are very comfortable with exposing and working with basal bone. So all of our guides are based on basal bone anatomy. Well, basal bone anatomy is extremely predictable. We don't pin our guides. Pins are inaccurate. Pins aren't stable enough. We screw them in, just like rigid fixation. So a lot of little nuances, but those nuances lead to accuracy. Our stack system does not pin. We developed cylinders and pistons. So the implant guides go into pistons, and then the teeth the pistons are on the guide or the teeth, and they go into cylinders, so that if there's any inaccuracy, you're going to see it. Whereas in a system where the guides don't contact, you can miss it. So we have to refine our situation until everything's perfect. It just makes predictable surgery. So Mike's a really good friend of mine. Actually, I've lectured at Mike's courses, and we've lectured together at various courses over the years. And I have, he sends some patients to me, and have the utmost respect. And certainly, end sequence is an extremely well established, extremely proficient group of people. The problem is you can't be more accurate than the base you're working on, and you'll never be accurate without alveolar bone. Not to the level we want to be.
Very impressive. Also, Doc has a training program. If you guys are interested, you can reach out. Tyler and April will talk about it a little bit more in terms of mentorship, where you could bring your own patient, but that's a different topic. Great explanation. So use a different system. Now, what are your thoughts about Europeans are printing now subperiosteals again? They're pinning them in. What is your thought there? They're saying it's less invasive.
Yeah, it's another good question. So the concept of subperiosteals, of course, goes back years and years and years and years ago. The problem is the biology of the oral cavity hasn't changed. And so the weakness of the system is not that you can't fit it to the bone, and it's not that you can't rigidly fixate it to the bone. The problem with the system is long-term integrity of the soft tissue interface to the system.
Yeah, I was looking at the literature.
And that
You're
is
right.
extremely well defined. And unfortunately, we don't really have a great way around that. Perhaps if you maybe a laser etched surface or something like this could modify that. I don't know that for sure. But the problem is that those systems left in place long enough usually will develop subperiosteal infections because it's a tracking mechanism. And once that happens, there's not much you can do to save it.
Yeah.
And so I don't think that that's a trend that I would be looking for. I mean, I think we have so much evolution of thought with what we're doing with dental implants now. I'm a pretty traditional guy. I still like to, have my 10 and 12 and sometimes even longer implants, okay? But almost every case we do will have short implants in the posterior. And they hold up quite well when the loads are distributed appropriately. So one of the things we looked at with our research is we don't have many implant failures. And I'm sure most of the doctors listening today are shaking their head, their implants don't fail very often. In full arch therapy, most of the failures are prosthetic. And that's because all materials fatigue over time. And, occlusal function it's an everyday thing. There's a constant stress on these materials. And so one of the things that we really did with our system is we eliminated almost all cantilevers. And we've done that either by shortening the arch form in some cases, or by adding short implants in the posterior, but we don't connect those with screws. We just make telescopic copings. So if you've got 4 anterior implants screwing, or even 3, screwing a prosthesis on, from a prosthetic perspective, you have all the retention you need. Then for the rest of the prosthesis, you only need resistance for it, resistance to bite force. So in the posterior, just telescopic copings with resistance, because when you limit holes in the prosthesis, you limit what are called stress concentrations. If you go to the engineering literature, any place you have a hole in a material, you'll have a 3x stress concentration over the surrounding areas. So, that's why all on 4 has, that's a good thing about all on 4, if you can limit your arch length, because you only have 4 holes. But if you can extend to, in some arches to 5 or 6, depending upon how big the face is, how big the bones are, now you can have telescopic copings in the posterior to extend the occlusion a little further posterior, but without the loss of integrity by just telescopic copings. Very easy to do, by the way. And for most restorative dentists, you don't have to take screws in and out further posterior in the mouth, which is always hard.
The telescopic copings, they snap on, right? Is there an issue of getting them off?
Well, we have a couple of different scenarios there. We have some parts that we can screw on. Of course, we've used ball attachments back there too. They work quite nicely, to be honest with you. We're in the midst of actually developing a printed solution for the telescopic coping, especially with some of the newer, stronger materials that we have now, the ones that you're using for a crown, most likely. So that's a nicely evolving thing. But any lab can make you a telescopic coping. It does not have to be a finite fit like a conus, because you're not using it for retention. You're just using it as a vertical stop. The 3 or 4 screws are going to hold the prosthesis on. That's all the retention you need. It's resistance for resistance to decrease rotational flex, or torque and vertical
pumping.
Yeah.
And pumping, yes, certainly. So it's very exciting to hear that you're also innovating things with these printers. I actually have invented a fastening system that I'm exploiting with that same printer for a conference call. And I think a lot of my colleagues here that are watching, they have this challenge with conversions. And a little bit ago in the green room, I brought up this topic. For me, the all-on-4s and the all-on-X cases became a challenge at the conversion stage, and then the lab technicians would come in, they would do it, and then there would be problems, and they would leave, and then I would have to deal with the problems. Maybe Tyler can give us an example or an idea of what it looks like at your office when you do a full mod case and how we convert them, and maybe a short run. That would be really appreciated. Tyler, you probably take a very integral part of this whole process, very important part. And I'm sure Doc is very happy to have you on his team.
That is a huge understatement. Tyler is an absolute genius when it comes to applying all of this knowledge, but he develops a lot. He has developed a lot of these solutions.
Yeah, tell us about how you do this conversions same day.
You can see my screen pretty well now.
Yes.
All right. Well, this is sort of a walkthrough. We've shown at a couple different conferences, but this gives a pretty good idea of how we do our conversions from the digital record taking all the way through to the surgery. So this is straight from the CBCT. And from our CBCT machine, we use CareStream, but pretty much any CBCT machine, you can derive an STL, or essentially a printable file from the CBCT that was taken. So this is the patient we're doing a lower arch on, and then we'll take and do an intraoral scan, and I'll take that record and match it to the CBCT.
And you do that in what software?
We use ExoCAD software.
Yeah.
and Exoplan for implant planning. So this was matched in Exoplan for planning the implants. And the software that you're looking at here is from 3D Systems. It's their 3D Sprint. It's essentially their loading software for the printer.
Okay.
It's a very powerful software.
You know, exocad is sometimes cost prohibitive for a lot of doctors when they purchase all the printer and equipment. So maybe you have some recommendations that are always designers you can outsource this kind of thing out to, but then you're never 100% sure they did it the way you want it, right?
You know, if you're
Exactly.
only doing lower level work, exocad does sell a version which is office-based version versus lab-based version, which is less expensive.
Oh, wow. That's good to know. Thank you for that. So guys, you can get exocad and it won't cost you $16,000-$17,000. It costs you less if you get the lower version. I'll look into that.
All right. Let's see.
So now you imported your intraoral scan, you combined it with your CT.
Exactly.
All right.
And then hold 1 second here. Then we just take this to go away. This is the create a reduction model based off of the implant placement. And then we'll go straight into using Exoplan. I create a base guide that allows our surgeons to cut very accurately.
So one thing about that bone reduction guide is it's applied to basal bone directly with no space in it. And so it hugs the bone impeccably. But Tyler also makes, on the maxilla, we don't need it, but in the mandible, he also makes another portion that goes into those cylinders that we index to the teeth before we take the teeth out. So that way we cross-check the vertical. Do you have that there to show, Tyler?
Yes, definitely. So then these latches here, I create those to match up with the base guide, and these latches never change throughout the entire case. So anything that we want to put onto the stacking system stays in the same exact position in a 3D space so that we're extremely accurate. And then here comes in the little placement guide. So this fits directly onto their arch, and then we'll bring the base guide up to this piece so that we know exactly where we are in a 3-dimensional space.
And that he'll have predefined screw holes for us to screw that in with, that we know will avoid implants.
All right. So then after taking off, let's see, let me take this away. Take this away.
This goes to show you how prepared Tyler is. We didn't even tell him he had to give this presentation today. And he's just ready to go.
So then,
So you separate your implants properly, you got the right spacing.
exactly. And then this shows you it's designed to have 0 space in between the implant placement piece and the reduction piece so that the surgeon knows exactly if they haven't reduced properly, this will not have a great fit. So if it's setting up any at all on one side or the other, they know that they need to level that bone just a little bit more until this is perfect marriage fit so that we know exactly where we are.
And then we found that pins, if you want to pin those systems together, the pins, believe it or not, are never perfectly accurate. So
they're not. I agree with you.
We use composite resin. We just put a little dab of resin where each piston goes into the cylinder, and it pops right off when we're ready to take it off. So that way we have no pins to give us inaccuracies. This is why we're so precise.
Yes,
So then
there's always a standard deviation, but you guys have created quite a interesting concept here. All right, so next you got your stackable guide, you got your final your temporary prosthetic there. So please, wow, that's good.
And then we even, in a lot of cases, we will print using the same NextDent. We have the 2 NextDent 5100 with 3D systems, and we'll print these models off that are articulated as well. Let's see if I can get this bone model to go
So
away.
speaking of articulation, how do you handle your articulation with the software and the printer and all
He
that?
showed it briefly at the beginning. He had the virtual articulator up there. He didn't really talk about it, but it was up there for just a minute. So we virtually articulate everything off of that CAT scan.
That's impressive.
It's built
Well,
into the
wow.
software. I mean, ExoCAD's a little bit expensive, but when you think of the time and work it saves and the accuracy that it provides, you know what it costs to go out and buy, a really high level articulator, right?
Yes.
Well, it's built into the software.
It's amazing. It's absolutely amazing. If you can get your CR right and you can do it digitally and proceed to the step, it's certainly worth it. And I mean, cost prohibitive in the eye of a dentist, to dish out $17,000 for software, but in a big scheme of things, that's like one arch, and you have your money back. So something to think about. But you guys recommend ExoCAD to be the best software to go with this, right? If you're getting
We've
into
looked
this
at quite a few softwares and we own a few others. Listen, there's other software out there that we use. We use other softwares too, but this is really in principle. If you want to do highly sophisticated, highly accurate, very reproducible work, it's the best.
That's the only way for this type of cases. It's all about accuracy. So very good to know. So thank you for that, Tyler. So you make all of this before we even touch the patient, right? That's
Yeah.
all
One
ready?
last, can you go back to that for just a second, Tyler?
Yeah.
If you don't
Yeah.
mind, I don't.
No, not
I
at
want
all.
to show one other nuance. He didn't point this out, but I think you can see it. If you look at the posterior implant emerging somewhat in the bicuspid region there, you see how it's parallel to the anterior implants?
Yes.
So one of the things we learned, now this is a case that does not have telescopic copings because it's only got 4 implants, okay? But one of the things we learned was that we don't have to put like if we have a tilted implant in the posterior, you don't have to put a multi-unit abutment on an angled abutment that brings the post straight up through the molar. Actually, if you'll change that to the 17 or 30 degree, that brings it forward and parallels it to the anterior implants, then your holes are smaller and it slides on much easier. And remember, the screw is just retention and it's still the interface of the cylinder to the multi-unit abutment that gives resistance to flexion. So it doesn't matter if that tips forward. You don't have a slide, one of the slides that shows that handy, do you?
They look pretty parallel to me.
I think it's an extremely important concept. The prosthesis strong. We use engineering to keep our prosthesis strong as well as material properties.
Excellent. These look pretty parallel to me. Why would you use an angle?
That's an angle, but it's an angled abutment accomplishing that.
I see.
Mhm.
I see. Above the guide. Okay.
Yeah. So
All
these
right.
are just a lot of little nuances that that over time we've just tried to build into the system. So it's very different than some of the other ones that are out there. But they make little things make a difference.
That's right. It's always the little things that differentiate us. So that was wonderful, and from the oral surgery and implantology perspective, do you guys print any other kind of prosthetics in your oral surgery office? What do you do?
We do quite a bit. And you were asking about ExoCAD and why we like it more than just about any other software we've played with is that it literally gives you so many things that you can do with it. So off of that same software, we do our TMJ bite splints, we do night guards off of that same software, same printer. We do Maryland bridges, immediate Maryland bridges, flippers. I can't think of anything.
Immediate restorations for our
immediate restorations.
Aesthetic zone, immediate immediate restoration of implants, whether it's a single implant or like a 3-unit bridge, with non-engaging abutments. We print all of that.
Amazing, which brings us to the next concept. Already over 200 chairs in different groups relating to implantology, I see. So this is going to be a very well viewed podinar. But the other half of the viewers that might not be just implant dentists or oral surgeons or periodontists for that matter, we have the general dentist. Now, I don't know what you guys' opinions are from the things that I hear about materials and improvements and accuracy and tolerance and fit. But what about crown and bridge? What about you're talking about being able to articulate dentures, 2-appointment dentures I'm seeing now that are coming out of these labs where everything is done digitally and articulated differently. So April, you're going to kind of give us a little bit of an introduction about those kind of findings. And before we get to that, I just wanted to get Dr. Spagnoli's opinion about printing permanent crowns. Where is this heading, Doc?
So
the material, from the material perspective.
I'll give you my perspective. And again, this is with great respect to the restorative dentists. I do have a couple of, I have a prosthodontist in my building, and he coaches me a lot too. The strength of the material that you can print now, highly filled, certainly meets the criteria for a crown. There's one huge benefit. In all of the history of dentistry, maybe other than lithium disilicate, we have luted our crowns onto teeth. Is that right?
Yes. Correct.
I know that there's a bit of lithium disilicate that may be bonded, but even there is primarily luting. This is the first time we have had a crown or 3/4 crown restorative material that we can etch and bond to the tooth.
Yes.
Now, that's a game changer because we know the weakness of any of these restorations is the margin. In addition to that, and this is some other work we have going on, not ready for prime time yet, is that we can take fluoride containing sealants, like pit and fissure sealants that you use in PEDS. We can even add other antimicrobials to them that are invisible. And we can now bond, after you cement the crown, another layer of sealant over the margin. That
would have a major impact on periimplantitis, which is a big problem. I mean, periodontitis.
Recurring. I mean, basically, the fact is if the seal is that good and it's bonded to the tooth, then the potential for recurrent caries goes way down. Now, we know that anything can happen, but the potential goes way down because now we have a bonded fluoride margin.
Wow. See, sorry I said periimplantitis because the first thing that shot in my head is the periimplantitis issue we have, which is one of our biggest issues in implant dentistry. So when you're using this kind of a scenario, you would also seal that better and prevent micropumping if you're bonded, possibly, and if you can prevent it from breaking that seal. There sounds like to be some primetime stuff coming our way, huh?
I think so.
That's lovely. Love to hear more about it and to have you back on the show. Thank you so much for your opinion, and Tyler for the demo. I think our colleagues are going to be more excited about this topic till they make the leap over on the other side of the fence. And April, maybe you can kind of do the presentation that you have prepared for the audience to kind of give them a brief overview of who, when, what, and where. And you have the floor.
Right, let me go ahead and share my screen here. Now, what I've put together is intended to be very basic information for folks who are thinking about 3D printing in office, but haven't quite stepped into that yet. So some of this is going to be, a step behind where you are already. It's certainly a step behind, several steps behind Tyler and Dr. Spagnoli. And for some of you, this is going to be some information to fill in the gaps that are kind of preventing you from taking that next step. I work with Nota 3D. We're a licensed distributor for 3D systems. And let me carry through here. So this is my contact information. I'll leave this up for a few seconds. Find me on LinkedIn. That is a QR code straight to my LinkedIn page. My direct number and email for any contact information. I would love to answer any questions that you have. We also have some specials going through not only this presentation, but anyone who does work with Dr. Spagnoli and Dr. Shah. Also, if you're interested in any mentor opportunities with Dr. Spagnoli, I can connect you with him through this information as well. So save my information. I'm going to put this up again at the end of the presentation. All right, so why have this discussion? We're not discussing if 3D printing is taking over, or if we should be 3D printing, but how. You're all watching this because you're either already printing or interested in getting into it. It is becoming the standard of care in a lot of aspects of dentistry because of its improved accuracy over traditional methods. One of the reasons we're having this discussion is I hear almost every day the extent of paralysis by analysis. There's so much information, so much misinformation available that we're taking on a personal challenge to re-educate people on how accurate and reliable this can be if done the right way. This is my 19th year in dentistry. I was a hygienist for most of that. And you can't take the education aspect out of me. I want to find a way to implement that even with this. And this is the opportunity to do so because of mass marketing and because of so many people jumping into the lucrative opportunity and lucrative realm of 3D printing. There are a lot of options out there that may not be in your best interest as someone who's stepping into printing. So we'll kind of get into that a little bit too. All right, so what is 3D printing? You're all familiar, whether you know it or not, with subtractive manufacturing. That's basically taking a solid block of something like a CERAC crown and removing material until you're left with the appliance or the prosthesis that you wanted. It's a slower process. It's a limited function. Most machines are made for just a few applications, such as crown and bridge. More material waste by quite a bit. You're, again, throwing away everything you don't need until you're left with the only thing you wanted. And more expensive. Not only are the machines more expensive, but that waste of material adds up as well. 3D printing is additive manufacturing. Basically, we are curing or adding material until we end up with the appliance we want. So we're not taking things out. We're not throwing things away. We're creating it from scratch by only using what we needed in the first place. So because of that, it's faster. You can print a crown in 15, 17 minutes, more potential functions. You know, this isn't one machine that can only print crowns. This is a machine, if it's the right machine, that can also print your night guard, your dentures, your custom trays, the works. Less material waste, like I said, because we're only using what we need, and cheaper. We're not throwing away product, and the machines themselves are cheaper than subtractive manufacturing. Little history overview of 3D printing. It was invented in 1983 by 3D Systems, which is who we represent. 3D Systems does not allow mass distribution, so you're not going to see their products advertised by Henry Schein, Patterson, things like that. You have to be a licensed, knowledgeable 3D printing manufacturer, 3D printing distributor to work with them. 3D printing started creeping into the dental field in the 1990s, really on the lab side. It wasn't until the last 5 or so years that it started becoming as popular as it is today in the dental field. And that's because as popularity increased and as competitors joined the market, prices came down and it became something that was physically and financially feasible for offices to do in-house. So it's not a new field, fairly new, effectively with in-house dentistry. A couple of types of printing that you're going to see. There are more types than this. These are the 3 most common. If we look at the far right, FDM, fused deposition modeling. This is, if you think of the 3D printers you can buy on Amazon or something like that to have at home to play with. There are certainly bigger, more industrial uses for these, but this is the type, if you picture the spool of material that kind of melts layer by layer into place. very slow process, very cheap process. So you're not going to find that with any of these dental printers, but that's the most common one that you'll see day to day outside of dentistry. SLA, that's a good one. It's not as fast and it's not as accurate. It's not as fast, but it is accurate. But because we're really implementing 3D printing in office for a high use of same-day dentistry, you're not going to see a lot of SLA on the market as well. DLP, this is the best use for dentistry because there's no heat involved. And you know, with heating and cooling, you're going to get some flexion, and that reduces accuracy. So anytime we can eliminate heat from the manufacturing process, we're going to have a more accurate product. Also, the projector doesn't move in this, which means there's less time wasted between cures. If you think of this process like curing composite resin for a filling, that's exactly what it's doing. It is light curing. And the more that has to move, the less accurate it's going to be and the slower it's going to be. So DLP is what you want to aim for if you're looking for speed and accuracy. All right, so with DLP being narrowed down as the type of printer you want, there are a lot of DLPs to choose from. One thing you want to look at is the size of the printer and the expected lifespan. If you look at these printers, we have some on the left side of the page and one on the right side. Both of them on the left and right side, both categories of examples have a UV filtered print space. That's kind of the orange or red space. Again, this is UV curing. So this is just like the little shield on your UV light that is handheld in office. It protects that resin from not curing when you don't want it to. All of those print spaces are about the same size. The biggest difference is you're going to see that on the left side, the body of these printers below that print space are very small, whereas the printer on the right side, very, very large. Feet difference, by about 2.5, 3 feet. That is because the one on the right has a professional grade projector. All of that bottom area is housing the projector. So you can imagine a projector that's taking up about 3 inches of space versus a projector that's taking up about 2.5 feet of space. That one's going to last a long, long time. It's made for speed. It's made for accuracy. It's made for professional level situations. If that doesn't matter to you, that's fine. A lot of people just want one that's fun to play with, and there are very inexpensive models that allow you to do that. So it really comes down to what you want to accomplish with it. What's possible with the right printer? Some printers are made for some very specific uses. If you just want to print models, there are printers that will just do that for you. The right printer is going to give you a lot of room to grow and a lot of flexibility. One of the benefits of additive manufacturing that we spoke about a few slides back was the fact that you can have one machine to accomplish a lot of goals with. So here we have all-on-X restorations, as Dr. Spagnoli was talking about, splints, retainers, permanent and preliminary crown and bridge, denture try-ins, custom trays, gingival masks, castables, surgical guides that are also autoclavable, indirect bonding trays, and models. So a lot of uses. Important factors to look at when choosing a printer. These are the 6 main areas that anytime you're getting a new piece of technology in the dental office, you have to make sure you're checking these boxes. Are you going to have support behind you? You and your team are not IT specialists. You're not supposed to be. You're supposed to be focusing on providing good dental care, and you should have a team behind you supporting you in the technology that you're investing in. That's not always the case. So that's something that you want to look and back check on whoever you're investing in to make sure you're going to have the support you need. Speed. If it's slower than now you're doing it already, it's not going to benefit you if you're trying to aim for same-day dentistry. Same with accuracy. If your lab is doing it better, your patients deserve for you to leave that alone and let the lab keep doing it. This is designed for you to take quality control and speed into your own hands. And in order to do that efficiently and ethically, it needs to be without reducing lab quality. Versatility, again, being able to use the machine for more than just one thing. Ease of use, this should be something that is predictable and routine enough that your team can use it so that you aren't investing your time in this extra step that you weren't having to do before. And affordability, it needs to be within range. Like anything else, there are really cheap low-end options. There are really high-end expensive options. That doesn't mean that they can do everything. Finding something that's affordable, that's going to give you a return on an investment that makes sense for your practice is important. So 3D Systems came up with the next step. So as I mentioned, 3D Systems invented 3D printing. They know what they're doing. They've been knowing how to solve problems in this realm for a long time. And when this started becoming very popular in dentistry, the NextDent was built to address these factors. One issue we were having in the last couple of years is a lot of people investing in more hobby style printers that weren't giving them the accuracy and the speed in office that they were hoping it would. This NextDent printer has been in labs all over the world for many years and working beautifully in all of them. So one of the ways that we addressed this issue was explaining to people that you don't have to get a small countertop hobby printer. If you're wanting to replace or remove some lab costs without losing lab quality, you can use the same printer the lab is already using. The same printer you may already be getting lab cases back that were printed on, but you're not paying the lab costs now. So again, great support. You not only have us as your dealer, you have 3D Systems behind us that are backing not only us, but you directly as well. Speed, you can print, again, a crown in about 17 minutes. You can also print up to 32 models in about 2 hours. So speed that is just unmatched. Accuracy, versatility, ease of use. Again, this is something we want to make sure your team is using for you so that you aren't having to spend your time doing this. And affordability, this machine is about $11,000. So for the same price that you would be spending on a hobby printer that's only designed to last a couple of years and only has a couple of solutions, you're getting a lab quality machine that's designed to last 10 plus years. It auto calibrates. It's the only machine that can auto calibrate. And if you aren't already printing, you won't know the headache of calibration yet. But for those of you who are, you know that you pour a resin in and it's kind of a best guess scenario until you get the right mixture of settings to get the proper print that you were hoping to get. Whereas this machine auto calibrates before every single print. So you're always getting what you were expecting to get the first time. Complete workflow with anything, you're going to need a print prep software. This comes with it. It's free. Any upgrades are free. It is yours for the life of it. Over 30 plus resins to choose from. So there's not going to be a job you're wanting to accomplish that we can't accommodate with a high quality resin. The printer itself and a cure box. Whenever you 3D print something in dentistry, it's going to come out just shy of completely cured. And that's on purpose. When you take off the little support nodules that hold it, that attach it to the printer itself, you want to be able to do that without scarring your print. And if it comes out completely cured, you risk doing that, or you just add more work for your lab tech or assistant who's in charge of getting that into the shape to where it's ready to be delivered. If it comes out slightly uncured, you're able to remove and do those manipulations without damaging your print. Put it in the cure box for a few minutes, then it's completely finalized and ready to place in the mouth. We have a porous print plate, build plate. If you look at the picture on the right side, you're going to see a very flat surface. Any printers that have a flat surface require adhesive forces to keep that print on the plate. Again, what we're trying to do is eliminate any reason for failed prints. You don't have time for failed prints, and it wastes a lot of money and a lot of chair time. So by having that porous print plate, you're not going to have prints fall off, as you can see in this picture here. This is our print plate that shows the porous feature, and it's actually building the prints attached to the plate, so they're not going to fall off. These are removed very easily. If you look at the spindles on the right side, you can see how they taper just to a needle width where it actually touches the prosthesis. So you're not going to get damage from removing those either. A few of the materials, this isn't by far going to touch all of them. It's just going to touch on some of the more popular and more frequent uses of it. But obviously model material, anyone in any field in dentistry can benefit from this. You do not have to have a model to print the actual prosthesis, but in-house aligners, things like that. If you need models, you know that you can make them at a higher accuracy than you would be able to pour them in stone with. And this is a picture of the auto stacking feature where you could print, again, the 30 to, I believe it's 36 models in just under 2 hours. Dentures, denture teeth, the entire denture workflow from custom tray to try-in to placement in the mouth. This is a picture of a denture. All that was done to this was the teeth were attached with adhesive and it was polished. No characterization has been done, but they are made to work with any glazing material that you already have, whether it's the dentures, the denture base, or crown and bridge, to add whatever customization or characterization you'd like. Crown and bridge material. This particular material is for really long-term preliminary or denture teeth. We have another material called Ceramco that I know Dr. Spagnoli and Tyler use. It's made for permanent crown and bridge. It's great with denture teeth and all-on-X restorations. Surgical guide is a big one. The big thing about this material is it's autoclavable. So you can design it, you can print it, you can pop it in the autoclave, and in 12 minutes, you have a sterile piece of equipment ready to go, designed specifically for your patient. We have several variations of kind of tenacity and flexibility with retainer and splint material. Castables, this is a big one for labs more so than dental offices, but another huge use that a lot of smaller machines aren't able to do. They're able to print it, but as you can see, there's a lot of little pieces and a lot of fine detail that could easily fracture. And again, because there's no heat involved, you're not going to lose any anatomy, any shape, any accuracy once these are printed and shipped. Gingival mats. Indirect bonding trays is a great one for ortho. So not only can you print 32 ortho models in a matter of minutes, but you can also print your own indirect bonding trays so that your complete workflow for ortho is in-house as well. All right, so we talked about the 6 main points of having great support, speed, accuracy, versatility, ease of use, and affordability. Whichever route you end up going with printers or scanners or even digital sensors for radiography, you need to make sure you're checking all of those boxes so that it doesn't catch up with you on the back end and you're left with that piece of equipment that you've invested in not working or not working for an extensive amount of time while you're waiting for someone to notice that you need help with that. In addition to that, it is possible to get a machine that is reliable every time, that has a resin for every application you're wanting to do, that has the training and support, whether you want it virtual or in-person, hands-on, that will nest and make the decisions for you to make sure your prints are as accurate and sturdy as you need them to be. No calibration. Long-lasting reusable resin trays. This is a big issue with a lot of other disposable trays. That expense adds up. High accuracy that doesn't fade over time. Again, we're talking about a big industrial projector that is made to consistently print perfectly for 10+ years, not something that you're going to invest in and a couple of years down the road have to reinvest in because you're working with a printer that's just a couple of inches high and not made for that extensive amount of use over time. And no hidden or recurring fees. It's yours. The software is yours. The licensing is yours. There are no sneaky upgrade fees that are ever going to come out of the back end and surprise you. So make sure that you are doing your homework and checking on these things before you're purchasing whatever piece of technology that happens to be. Partnership pricing. We do reduce pricing for anyone who currently works with Dr. Shah or Dr. Spagnoli or who does in the future. We are very heavy on education, and so are these guys. It's really important to us. It's the root of who we are. Anytime we work with them, we know that they're going to take care of you the way that we are. So that's really the basis of our partnership with them. And that holds true in the pricing. that is being extended to anyone who views this Podnar through the end of September. So start a conversation with me between now and then if this is something you may be interested in, and I'll be able to take care of you the same way I would if you were working directly through Dr. Shah or Dr. Spagnoli. Reach out to me, even if it's just to ask me additional questions about 3D printing or to see if this is even right for you. It may not be right for you. What you're currently doing may be your best fit, but it may not be. And we can kind of break down where you want to go with your practice and what you're comfortable with to figure out what that right answer for you is. This is a QR code that takes you directly to our website with more information about not only who we are, but the printer, the materials, everything accessible to you. And this is my information again. Again, I encourage you to find me on LinkedIn. It's a QR code straight to my LinkedIn page. You can access me anytime. I check it every single day. This is also my direct line and my email. I love discussing the educational aspect of this, and I would really love to take on any conversations that you have for me. It's not a one-size-fits-all thing. It certainly shouldn't be. This is very specific to what you and your patients need and what your staff needs as well. So reach out to me, start that conversation, and we'll take it from there.
Wow, thank you so much, April, for this wonderful presentation. We really appreciate you. I had a very pleasant experience with you and your team in terms of from A to Z, from the setup to the orientation, to the materials, to et cetera, et cetera. I thank you for coming on to the show. I thank Dr. Spagnoli and Mr. Britt to also join us to sharing knowledge, this is all we are about here at this Global Summits Institute. And gladly invite you to Italy. Dr. Spagnoli, do you have any Italian background?
All of my family came from Italy.
Lovely.
So 100% Italian descent.
Something was telling me that. So you're highly welcome to join us in Sardinia. We'll send you a personalized invitation with Mr. Britt also. I think you'll find that to be a very pleasant experience. I was there this year. Have you been in that area of the world, on that island?
I've not been to that island, no. I love going to Italy, but I have not been there, so it would be a new experience.
Lovely. The VIP invitation is forthcoming. Thank you guys so much for your time. We look forward to having you in the future, especially if you have any developments, which I think you are working on, that you share that to us as well with our audience. They would appreciate it. Thank you.
We will. It's a pleasure to have a chance to participate with you.
It's an honor. Wish you guys a great Sunday, and look forward to having you back on. Thank you.
Thank you, Dr. Shah.
Thank you.
Bye.
Yeah.